looking at, it's not really worth the time. Let's turn ahead then to 3.1. Sorry, 3.3. And 3.3 is trying to bring together the ideas that we've had so far. Yeah.
We never went over problem 43, the Phillips curve.
Right, 43, the Phillips curve. It's not worth the time it takes.
Okay.
So let me skip that. So number 3.3. So this is now bringing together a lot of what we've learned so far. They're saying use the limit definition and remember that I said that on our midterm you're going to have a couple of these. I know that some of you have had this before, and you know what we're doing. We are collecting patterns. And so these patterns get collected together in, 4.1. And in 4.1 we learned the shortcut rules. Really what we're doing now is we're proving these shortcut rules. But after you learn them, then from then on you can go ahead and use the shortcut rules. So it's only for the first couple of problems that you got to do them the hard way from the definition. If you've had this before, you know that the prime mark is the abbreviation for derivative. And you know the shortcut, that the derivative of just x to the first power, that's 1. And 5, the coefficient stays. And -3 is just a constant. The derivative of a constant is 0. So what we're going to show is we're going to use the limit definition there on problem 1 in order to conclude that. So here's the limit definition. The derivative, f prime. That's just the abbreviation for derivative. It's this limit as h goes to 0 of f of x plus h minus f of x all over h. Now, in chapter 3, we've tried to motivate why this definition makes sense. Without the limit, what you have is distance traveled over time elapsed. That gives you average speed. But if you take the average speed over a shorter and shorter and shorter interval, you get closer and closer and closer to the instantaneous speed. You need a complicated formula like this in order to get instantaneous speed because you can't divide by 0. This whole thing is getting around the problem of division by 0. And so, in 3.2, what we did is we computed the derivative, the instantaneous speed, at a particular point in time. X equaled 1, x equaled 3, x equaled 7. But as we did those problems, I tried to point out to you that if you simply left x as x, the same algebra works. And so that's what we're doing now. We're finding the derivative in general for any general x. So first thing we do is let's apply the function. And here again, I just remind you, what is a function? It's a set of instructions. It says 5 times it subtract 3. Well, that's what we're going to do. That's what we're going to do here and here. Let's apply f. So this is the limit as h goes to 0 of. So here in blue, our first term, take the x plus h and plug it into the box. In other words, it's 5 times x plus h, subtract 3. That's our blue step. And now, the green step. Put x into the box, which of course is your original definition, 5x minus 3, all divided by h. Are we okay? You're going to have 2 of these on the midterm to do, so ask any questions. Now what you do is simplify the algebra. So this is the limit as h goes to 0 of 5x plus 5h minus 3 minus 5x. And be careful here. Here's a common mistake. You distribute this negative over the green bracket. Negative 3 is positive 3. So it's a common mistake. People keep that a negative sign. No. Negative is positive. And now look at all of your nice subtraction. 5x subtract 5x, negative 3, positive 3. And what you're left with is the limit as h goes to 0 of 5h over h. And maybe you think this is a bit of casuistry. Maybe it is. But the whole idea of limit is that h is getting tiny, but it doesn't equal 0. Because h is not 0, then you can cancel common factors. Because you see, 0 over 0 would be meaningless. Or 0 over 0 is ambiguous. In one situation, it might be 0. In another situation, it might be 13. In another situation, it might blow up. It's ambiguous. Ambiguous things in math don't exist. So, because h is not 0, you can cancel the common factors, and you're left with just 5. And here, don't overthink it. 5 is a constant. As h goes to 0, 5 is 5. As h goes to 17, 5 is 5. It's a constant. So your answer is 5. Which is what we predicted. I'm going to say something you don't care about. Division by 0 is the difficulty about instantaneous speed. Because average speed is distance over time. But how can the denominator be 0? So historically, calculus was discovered simultaneously in the 17th century by Isaac Newton and Gottfried Leibniz in Germany. The way they did it back then, the way they got around this problem was that in the 17th century, they talked about an infinitesimal. An infinitesimal was some magic creature that existed somewhere between a point and a line segment. You know that if you take a point, there are an infinite number of points in a line segment. One point alone has no length, and a line segment has an infinite number of them. Well, an infinitesimal is some kind of creature in the middle. One infinitesimal has no length, but in a line segment there are a finite number of them. Huh? One alone has no length, but a line segment has a finite number of them, and a line segment does have length. What kind of creature is an infinitesimal? Well, for 200 years they did calculus using infinitesimals until it accrued all kinds of contradictions. And that's when in the 19th century they threw out the whole idea of infinitesimal in the 19th century, and they went to limits. Now, in a Calc 1 class, so, okay, you guys, you know, in your business class, you can take 1070, 1071 that fulfills your requirement. If you, say, are oriented to being an actuary, instead the 1131, 1132 will fulfill your requirement. That's the calculus for the science majors. So if you're actuary bound, you really need to take more serious calculus. And it's in the 1131 that we go into a proper definition of limits. It's more complicated than I've made out here. You know, we talk about epsilon delta arguments. But, you know, you don't need to know this. I'm only throwing this out. If there are any actuary bound people, you really need to take the 1131, 1132 series. As long as I'm talking. At UConn, you've got 2 actuarial tracks. There's one in the business department, but there's another actuarial track in the math department. Yeah, the math department is harder, but you know that in order to become a CPA, you have to pass 10 exams. If you are an actuarial major in the math department, they guarantee you'll pass the first 3 of them by your senior year. So, I don't know if that applies to anybody here. Just thought I'd throw it out. Okay, let's move on. 3. So here our f of x is x squared plus 4. All right. The real reason we're doing this is to come up with these patterns, these shortcuts, that from now on, after chapter 3, we can fall back on. And what we're going to see, and in fact we did one of these the other day, and I did point this out to you. X squared has its derivative 2x, and 4 is just a constant, its derivative is 0. So the derivative of x squared is 2x. We did a problem like that. And the derivative of 4, a constant, is equal to 0. But we want to use the limit definition. So f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So the first thing we want to do is apply f. And then just to remind you, a function is a set of instructions. What are these instructions here? Square it, add 4. Square it, add 4. Those are the instructions. Do those instructions here in blue. Do those instructions here in green. So you're looking at the limit as h goes to 0 of, here in blue, take x plus h and put it into the box. X plus h into the box. The instructions say square it, add 4. There is your blue. Minus, here is your green. F of x, put x into the box, which was what you began with, x squared plus 4. Divide that all by h. Okay, before we go on, I grabbed my red pen because there's a problem here. When people often go to work this f of x plus h, so this blue step here, this problem occurs in the blue step. And if I see you doing this on the exam, I don't have to read any further because you're done. Don't do this. People say, okay, I know that f of x is x squared plus 4, and I guess I should just put the h on at the end. They write this instead of the blue box. No. You see, what they've done is that they've done f of x okay, but they've added on the h. F of x plus h is not the same thing as f of x plus h. That's not f of x plus h. Are we okay?
I
Yeah.
have a question. Why is it that you substitute x plus h into the x for the first set of brackets?
Okay. Let me give you two answers. One, how you do it, and second, why you do it. So, how you do it, the x plus h is supposed to go into your function. And remember, your function is a set of instructions. This x here really is not that x there. They're different things. The x here is a placeholder, which is why I've resorted to going back to the old box idea. So we'd be better off, really, I suppose, instead of writing f of x, writing f of box. Because you see, this x here is not that x. This x here, the x plus h, think of it as a three-letter word. And you're putting that three-letter word into the box. Okay? So that's how to do the problem. And again, why? Why is that? Remember where this comes from. You know, you've got a ball that's falling. And if you consider the average speed, okay, say the interval starts at x, and the interval is h seconds long, so the interval stops at x plus h, and you want distance traveled. So that's going to be your finishing distance. So the interval starts at x, it stops at x plus h, so the total distance at the end minus the distance at the beginning gives you distance traveled. That's where it comes from. Make sense?
Yeah, thank you.
Okay. So are we, okay, don't make this red mistake. You know, I say this over and over and over again. 1/3 of you will make this mistake. I don't mean to be pessimistic, it's just, I've graded your parents for a long, I've graded your papers for a long time. I mean, I used to say that I graded your parents. I graded your grandparents. And so now, if you're with me this far, now it's algebra. Expand your square, x squared plus 2xh plus h squared plus 4. Are we okay? That's the blue parenthesis. And here you have negative x squared minus 4. Remember to carry the negative sign over to the 4. Are we okay? And now nice subtraction. X squared, subtract x squared. Positive 4, negative 4. And you don't have to recopy. You could go ahead and factor, but allow me to recopy for emphasis. So you have only two terms left. They share a common factor. Factor an h out of the numerator. Two terms, share a common factor of h, factor the h out, and now you can do the limit thing. Because h is not 0, you can cancel. So now you're left with the limit as h goes to 0 of 2x plus h. Now, you no longer have division. Now it is legal to plug 0 in for h. And someone was asking me about this after class the other day. Couldn't we think of it this way? Sure. H is getting tiny, tiny, tiny. And so you've got 2x plus a vanishingly tiny number, which is 2x. Yeah. So however you want to think about it, notice that we have justified our pattern. Let's keep going. Okay, number 7. Here our y, or you want to call it f, I don't care, is equal to negative 2x cubed plus x minus 3. Okay. The reason why we're dragging you through all of these is to get you to see the patterns. Why are these patterns true? So the derivative, you could call it y prime. You could call it f prime. That's the derivative. You're going to be learning these patterns. And so I'm about to show you where we're going. X cubed. The derivative of x cubed, the 3 comes down in front, and the new power is 1 less. That's the pattern we're going to be seeing. That if you had x to the n, the derivative is n, x to the n minus 1. The power comes down in front like a coefficient. The new power is 1 less. And coefficients stay. You see, you have a coefficient of negative 2. A coefficient stays. Why? We're about to see that. We're about to see that. Then, we've already seen the derivative of x. The derivative of x is 1. We've already seen that. And negative 3 is a constant. Its derivative is 0. So, these patterns are what we're trying to justify. So let's do it. I take the limit, here's my definition of the derivative. The limit as h goes to 0 of f of x plus h minus f of x all over h. So the first thing we do is apply the function. And again, I hope this helps. The x here in your function is different from the x there on the x plus h. This x here in your function is just a placeholder. It's technically called a dummy variable. You know, in cards, a dummy is a card that you can call it anything you want. It's a dummy. And so this is really a dummy variable, which is why I replace it by the box, to try and get across to you the idea that the function is a set of instructions. The instructions are cube it times -2, add it minus 3. Those are the instructions. Those are the instructions that we do here and here. So the limit as h goes to 0 of, let's first do the blue, which says -2 box. Think of the x plus h as a 3-letter word. Don't break it apart. Put the word in the box. It's x plus h cubed plus box minus 3. All of that is the blue bracket. And now you subtract the green bracket, which is just f of x. Yes, which is just that. So in this case, the variable is the same thing as the dummy. So if you put the x into the box, you get the same -2 x cubed plus x minus 3. All over time elapsed. Are we okay? Yeah.
Why do we write, I know we have x plus h cubed, but why do we write x plus h again?
Because remember the function you were given. It had 1 term, 2 term, 3 terms. It had 3 terms. So when you think about the box, the f is a set of instructions. It's got these 3 terms to it. So you have to take the x plus h in each of the terms. Does that make sense?
Oh, yeah.
Yeah, the reason you have this x plus h here is because you had, they gave you that there, which meant that there.
Typically for cubes, like anything with like cube equation, do you write like x plus h again? Because that one was like square, we didn't deal with that. Is that like a cube type of problem? Okay.
Yeah, so remember, was it last time, I don't remember, was it last time we talked about these, a little bit of algebra here? If you had a plus b squared, you're all happy with that. You all remember that's a squared plus 2ab plus b squared. But I think we talked about this the other day, and we need it right now in this problem. If we've got a plus b cubed, I recommended that if you don't remember that, you learn it, because that's a cubed plus 3 times a squared b, 1 fewer a, 1 more b, plus 3 times 1 fewer a, 1 more b, and finally all b's. So yeah, that's the algebra rule for how to expand a cube. And yeah, I could give you one of those. So you're going to have this limit problem. There will be 2 of these on the first midterm. None on the second midterm, because the second midterm is not cumulative. But the final is, and I have two more of these on the final. So you gotta be able to do this. All in all, you'll have 4 problems. And again, someone asked at the end of the hour last time, if you wanna know what's on the test, go to my website, not UConn. Go to my website, the address is on the back of your syllabus. And you'll find study guides for both midterms and the final. The structure of my exams is the same term after term, I just put in new functions. So you can see the study guide. Okay, now, are you ready for this? I'm going to expand that cube. And I'm going to do it a step at a time. And if you can combine some of these steps in your head, you're welcome to. But what I'm going to do, I'm going to leave the -2 outside. Maybe you do that step in your head, you're welcome to. But let me expand the cube. X cubed plus 3x squared h plus 3xh squared plus h cubed. I just did this to x plus h cubed. And then let me recopy the x plus h minus 3. That all is my blue bracket. Minus, I won't do anything yet to the green bracket. And now I'm going to distribute the -2 across the parentheses. You know, you distribute multiplication. And maybe that orange step you would have done in your head, you're welcome to do it in your head. So here I have -2x cubed minus 6x squared h there's nothing wrong with the -6. I probably should have left it -2 times 3 so you could see the pattern, but I didn't. Plus -2 6xh squared minus 2h cubed plus x plus h minus 3. And now here, let me distribute the negative sign. -2x cubed minus x minus minus 3 all over h. Are we okay? Distribute that negative sign. And now look at all your nice subtraction. -2x cubed, positive 2x cubed. Positive x, negative x, -3, positive 3. You'll always have nice subtraction. And what are the terms you have left over? 1, 2, 3. You've got 3 terms left over. I'm going to recopy. -6x squared h minus 6xh squared minus 2h cubed all over h. And maybe you could do this step in your head, you're welcome to it. You got 3 terms. Take out the common factors. This is the limit as h goes to 0 of. Pull out the common factor of h, leaving you a -6x squared minus 6xh minus 2h squared all over h. Yeah?
In the previous step, there's plus x plus h. You canceled out the h. No, one down. Yeah.
Thank you. I got sloppy with my orange ink, thank you. I would have made a mistake. 1, 2, 3, Boy, I missed that plus h. Thank you. That would have cost me. 1, 2, see, I got sloppy, canceling out my x. I had a plus h there, which means here I have a plus 1. So when I factor h out, I have a plus 1, thank you. And now, h over h, I can cancel common factors because h is not 0. And so I'm left with the limit as h goes to 0 of negative 6x squared minus 6xh minus 2h squared plus 1. Thank you, I'm sure glad for that plus 1. And so now you see h is going to 0. So h is going to 0, 6xh goes to 0. Plug 0 in for h if you want to think of it that way. That's going to 0. So all you have left is the negative 6x squared plus 1, which is what you predicted, right? Negative 2 times 3 is negative 6. So that is what you predicted. And do you see, I told you that the derivative of x cubed was 3x squared. Do you see where it comes from? When you expand the cube, the x cubed, yeah, that is subtracted away. But this 3x squared has only one h attached to it, and that h gets factored out here, which is why that term has survived. So that's why you now see why the derivative of x cubed is 3x squared. Because it's only the second term of your expansion that has survived to the final answer. Now, I realize I'm getting a little ahead of myself. And let me talk about it. You know, if you had, instead of cube, 4, 5, if you have any power n, there is a way of expanding this. You don't need to know this. I'm only pointing it out to you. This is called the binomial. It expands x to the n plus n x to the n minus 1h plus, well, it's n minus 1 x to the n minus 2 h squared. But all of these things have higher powers of h. And so as h goes to 0, they disappear. The x to the n is subtracted out, which is why n x to the n minus 1. You factor the 1h out and cancel, and that becomes your answer. So this is called a binomial expansion. You do not need to know that. We don't even do that in 1131. But I'm just pointing it out to you that it's from the second term that you get the derivative. Just like up here, when you did the second term, 3x squared h, the 3x squared h. That is what survives and becomes your derivative. Which is why here is your pattern. The derivative of x to the n is n x to the n minus 1. That's the pattern we're picking up. Right, let me see here. 10 minutes. I've warned you about this problem before. Let's go to here. So the negative 6x squared h minus 6xh squared minus 2h cubed plus h all over h. So the correct way was in black. 1, 2, 3, 4. You got 4 terms in the numerator. They all have a common factor of h factored out and canceled. Here's the mistake. Somehow people just cancel the first h. I mean, what they're doing is this. If you have ab plus c over a, what they're doing, ab plus c over a, somehow they're canceling those a's. You can't do that. You can only cancel a common factor. Factor's got to be common to all of those terms. Okay. Let's take a look at number 9. Fractions. You all love fractions. Here, our f of x, or our y, call it what you will, is 1 over x plus 2, where it's understood, you know, you can't divide by 0, right? So it's understood x can't be negative 2. But what I want to show you, there is a pattern here. A little different. You see, this is the first problem we've encountered that's involved division, 1 over. And so there is something called the quotient rule, and we're going to be learning that in 4.1 or 2. And so we're going to learn that the derivative here is negative 1 over x plus 2 squared. There's something called the quotient rule. So what we're doing right now is we're warming up to the quotient rule. Just in passing, you could also work it using the chain rule, whatever that is. That's what we're going to be doing in chapter 4. Okay. But let's do our usual stuff now. We want the limit as h goes to 0 of f of x plus h minus f of x all over h. Well, focus on the blue, focus on the green. So we're going to apply f, and remember, f is a set of instructions. This x here is just a placeholder, or they call it a dummy. Those are the instructions. F of box is 1 over box plus 2. So here in blue, you're looking at the limit as h goes to 0 of, put x plus h in the box, 1 over x plus h plus 2. Minus f of x, put x in the box, 1 over x plus 2. Over h. Okay, now, I don't care what algebra steps you use. Here's the easiest one. Let's talk about algebra. If you've got 1 over A minus 1 over B all over C. That is called a compound fraction. A fraction of fractions. Your numerator's got fractions in it, that's called a compound fraction. You don't have to do it this way, but this is the easiest. The easiest way to simplify compound fraction is to clear denominators. What that means is multiply top and bottom through by the product of the denominators. Multiply top and bottom through by the product of the denominators. Do you see why that works? 1 over A times AB is B. 1 over B times AB is A over C of B. Do you see in one stroke I cleared my denominators? That's the easiest thing to do. So what I'm going to do is I'm going to multiply this whole thing through by the product of the denominators. And I'm getting crowded, so let me come over here. Let me recopy. Limit h goes to 0 of 1 over x plus h plus 2 minus 1 over x plus 2 all over h. So what I'm going to do, I'm going to multiply through by 1. I mean, it's the product of the denominators. X plus h plus 2 times x plus 2 over x plus h plus 2, x plus 2. And now you see why it works. Because you're going to take this product and you're going to distribute it there, and you're going to distribute it there. And each denominator cancels. So you're left with the limit as h goes to 0 of. So when you distribute here, you only have the x plus 2 left. When you distribute here, you only have the x plus h plus 2 left. And the denominator is the product of all three of them. Are we okay? That's the step I did. And now we're almost done. Look at how your numerator simplifies. Distribute this negative sign over the terms. Look at the subtraction. X subtracts x. 2 subtracts 2. We're left with negative h. We're left with a negative h over h, x plus h plus 2, x plus 2. And so now you see you can cancel the common factor because h is not 0. You cancel the common factor. And you're left with the limit as h goes to 0 of, well, you got a negative 1. You cancel h over h to have negative 1. X plus h plus 2, x plus 2. And now, you no longer have division by 0. If you put 0 in for h there, you just have x plus 2. So you end up with x plus 2 times x plus 2, which is negative 1 over x plus 2 squared, which is what I predicted in purple up here. Okay? So this might have been a tad harder because it was a compound fraction. Will I give you a compound fraction? Yeah. Either the midterm or the final, one or the other. So keep working. Come Monday, we'll finish off 3-3. See you Monday.